We'll start in 1 minute. All right, today we'll be in section 9.8 on how to solve quadratic inequalities. We've solved other types of inequalities, and so there are some similarities that will come to mind. And keep in mind, this Friday is test 4. It will be Zoom proctored, and we'll be able to review for test 4 on both Wednesday and Thursday. Okay, let's start some of the problems in section 9.8. We'll solve each inequality and then write the solutions in interval and algebraic notation. You can see that the left-hand side is a quadratic expression. It has the form ax squared plus bx plus c. And the right-hand side is 0. We always want one side to be 0. And we're going to see if we can divide the number line into separate intervals with endpoints. So to find the endpoints, we solve an equation. Find the endpoints by solving the equation you get by replacing the inequality with equals. And we can solve this easily by factoring. One factor is x minus 3, and the other one is x plus 2. I'm really fouling up today. I'll be awake in a minute. The two factors are x plus 3 and x minus 2. So the way that I caught my mistake was to visually multiply. Negative 3 plus 2 is not positive 1. So I was able to catch my mistake. Okay, the two solutions to this equation are negative 3 and positive 2. So the endpoints of the intervals are x equals negative 3 and x equals positive 2. So just like we did with other inequalities, we plot the endpoints on the number line. These two endpoints divide the number line into 3 separate intervals. And then we pick a test point from each interval. And then in the inequality, we test the endpoints, or test the test points. So in the first interval on the left, we can pick x to be negative 4. And then in the inequality, we have the number negative 4 squared plus negative 4 minus 6. Do the arithmetic. we have 16 minus 4 minus 6, which is positive 6. The inequality is less than or equal to 0, which is false. So none of the numbers from negative infinity to negative 3 are solutions. In the middle interval, the second interval, pick any number between negative 3 and 2. Since 0 is in that interval, I'll pick x to be 0 for the test point. And then in the inequality, replace every x with 0. So this time we get 0 squared plus 0 minus 6. That's equal to negative 6. The inequality is less than or equal to 0, and that is true. So all of the numbers between negative 3 and 2 are solutions. And then finally, in the third interval, pick a number greater than 2, so I'll pick x to be 3. And then in the inequality, replace every x with 3. So this time we have 3 to the second plus 3 minus 6. 3 to the second is 9. 9 plus 3 is 12. 12 minus 6 is 6. And the inequality, 6 less than or equal to 0, is false. With quadratic inequalities, it's pretty easy to tell if the endpoints are included or excluded. If it's less than or equal to 0, the endpoints are included, because if you test the endpoints, you'll get 0 less than or equal to 0, which is true. It's the or equal to 0 that makes it true. But in this first one, let's go ahead and test the endpoints in case there's any confusion. So first we'll test x equals negative 3. So the number negative 3 squared plus negative 3 minus 6. The number negative 3 squared is 9. 9 plus negative 3 is positive 6. 6 minus 6 is 0. And the inequality is less than or equal to 0, which is true. It's the or equal to 0 that makes it true. Testing the other endpoint, x equals 2, we get 2 to the second plus 2 minus 6. 2 to the second is 4. 4 plus 2 is 6. 6 minus 6 is 0. And 0 less than or equal to 0 is true. All right, so graphically, since the endpoints are included, we put brackets at the endpoints and then all of the numbers in between. The algebraic notation, negative 3 is less than or equal to x, which is less than or equal to 2. And then the interval notation is bracket negative 3 comma 2 bracket. This top one is the algebraic notation. And the second one is the interval notation. Okay, that's all there is to it. So we'll practice a bunch of other ones. but we'll see different situations. This one, y to the second plus 3y is greater than or equal to 4. So we would like one side to be 0, so we'll subtract 4 from both sides, and we'll get y to the second plus 3y minus 4 is greater than or equal to 0. Okay, so to find the endpoints, we solve the equation y squared plus 3y minus 4 equals 0. Well, this one can easily be solved by factoring. So one factor is y plus 4. The other factor is y minus 1. And the two solutions are y equals negative 4 and y equals positive 1. So those are the endpoints. Okay, so just like we did in the previous example, we divide the number line into separate intervals, 3 separate intervals. And then we go through the tedious process of testing the endpoint, or testing the intervals. The first interval on the left, pick a number less than negative 4. So I'll pick x to be negative 5. We can use either of the inequalities to test. Sorry, it's not x, it's the variable y. So we're picking y to be negative 5 for the test point. But you could use either of the inequalities since they are equivalent. Another option, since we were easily able to factor the quadratic expression, we can write the inequality in factored form. So the inequality in factored form is y plus 4 times y minus 1 is greater than or equal to 0. And sometimes it's handier to use the factored form for testing intervals. So I'll just show you how to do that on this one. If y is negative 5, then this factor, negative 5 plus 4, is negative 1. And the other factor, negative 5 minus 6, sorry, negative 5 minus 1 is negative 6. And then negative 1 times negative 6 is 6. And the inequality greater than or equal to 0 is true. Then pick a test point in the second interval, pick any number between negative 4 and 1. So I'll pick y to be 0. So I have 3 options. I'll use this option right here, this inequality, the original one. Replace every y with 0. We get 0 squared plus 3 times 0, which is 0. The inequality is 0 greater than or equal to 4, which is false. So none of the numbers in the second interval are solutions. Every number in the left interval is a solution. And then the third interval, pick a number greater than 1. So I'll pick y to be 2. This time I'll use this inequality. You can use any one of the three. So this one, 2 to the second plus 3 times 2 minus 4. So 2 to the second is 4. 4 plus 6 is 10. 10 minus 4 is 6. The inequality is greater than or equal to 0 on this one. And that is true. Since the inequality is greater than or equal to 0, for a quadratic inequality, we are going to include the endpoints. We include the endpoints. If you remember, the endpoints in this inequality, they are the y values that make the left-hand side 0. And 0 greater than or equal to 0 is true. All right, so graphically, since the endpoints are included, we put a bracket at -4. And the interval to the left is part of the solution set. And then at the other endpoint 1, we put a bracket that opens to the right and shade everything to the right. Okay, so now we'll write the algebraic notation. The variable is y, so if y is a solution, then y is either less than or equal to -4, or y is greater than or equal to 1. That's the algebraic notation. And the interval notation, parenthesis, -infinity, comma, -4, bracket. And then the union symbol and y greater than or equal to 1 is a bracket 1, comma, infinity. So the top one is the algebraic notation. And the second one is the interval notation. Okay, the next example is a little bit more involved, but the concepts are the same. Okay, solve this quadratic inequality. Y to the second minus 2y plus 7 is greater than 0. So we want to see if we can find the endpoints. So we find the endpoints by solving an equation. Y to the second minus 2y plus 7 equals 0. even though every polynomial is factorable, this polynomial, y to the second minus 2i plus 7, cannot be factored with integer coefficients. So we'll just use the quadratic formula to solve. So use the quadratic formula. So for this one, A is 1, B is -2, and C is 7. So y equals the negative of -2 plus and minus the square root of the number -2 squared minus 4 times 1 times 7, all divided by 2 times 1. And in the numerator, the negative of -2 is +2, and then plus or minus the square root of -2 squared is 4 minus 28. 4 times 1 times 7 is 28, divided by 2. So we get y equals 2 plus and minus the square root of -24 over 2. The solutions for y are non-real numbers. So when we tried to find the endpoints, remember the endpoints are supposed to be real numbers on the real number line, but these are not real numbers. So these solutions are non-real. So what does that mean? The number line is not divided into separate intervals. So there's only one interval to test. So this means there is only one interval to test. The interval between -infinity and +infinity. Okay, so let's draw the number line. So pick any number you want between -infinity and +infinity for the test point. -10,314,000. That would work. But we might as well keep it simple. So how about if I pick y equals 0 for the test point? Replace y with 0. We get 0 squared minus 2 times 0 plus 7, which simplifies to 7, and 7 greater than 0 is true. So that just means every real number between -infinity and +infinity is a solution. So all real numbers are solutions. The interval notation is parenthesis, negative infinity, comma, infinity, parenthesis. Okay, so that's the interval notation. And there's really not a very nice algebra. Well, we could dispute about whether it's nice or not, but when every real number is a solution, we just say all real numbers are solutions. But there is an interval notation for that, negative infinity to positive infinity. Okay, the next example, solve this inequality. 2x squared minus 7x minus 6 is less than 2. Step 1 is to subtract 2 from both sides, because when we solve quadratic inequalities, we want one side to be 0. So 2x squared minus 7x minus 8 is less than 0. So let's find the endpoint, find the endpoints. By solving the quadratic equation. 2x squared minus 7x minus 8 equals 0. So let's just use the quadratic formula, where a is 2, b is negative 7, and c is negative 8. So x equals the negative of negative 7 plus and minus the square root of the number negative 7 squared minus 4 times 2 times negative 8, all divided by 2 times 2. And then the arithmetic. The negative of negative 7 is 7, plus and minus the square root of 49 minus 4 times 2 times negative 8 is minus negative 64, all divided by 4. And then x equals 7 plus and minus the square root of 49 plus 64, because 49 minus negative 64 is 49 plus 64. So this is the square root of 113, all divided by 4. The square root of 113 cannot be simplified, but the solutions are real numbers. So the endpoints are irrational numbers. One endpoint is 7 minus the square root of 113 over 4. And the other endpoint is 7 plus the square root of 113 over 4. Okay, in this space down here, I'll draw the number line with the two endpoints, 7 minus the square root of 113 over 4, and 7 plus the square root of 113 over 4. So we have 3 intervals to test. So one of the things to watch out for when you're picking a test point from an interval, you'll want to make sure that the point really is in that interval. So the square root of 13 is between 10 and 11. So a number that's smaller than 7 minus the square root of 111 over 4 is -1. But if you want to make sure that you're in that interval, you can move farther to the left. So just to be safe, I'm going to pick x to be -2. You also have you're also allowed to use a calculator, so you can find 7 minus the square root of 113 divided by 4. You'll find that this is greater than -2. Okay, so in the inequality, replace x with -2, we get 2 times the number -2 squared minus 7 times -2 minus 8. And then do the arithmetic. The number -2 squared is 4. 2 times 4 is 8. 8 plus 14 is 22. 22 minus 8 is 14. But the inequality is less than 0. So 14 less than 0 is false. In the second interval, since the left endpoint is negative and the right endpoint is positive, 0 is in the middle interval. So I can pick 0 to be the test point. And then in this inequality, if I replace every x with 0, I get -8 is less than 0, which is true. So all of the numbers in the second interval are solutions. None of the numbers in the interval on the left are solutions. And then in the third interval, pick a number that you know is greater than 7 plus the square root of 113 over 4. The square root of 113 is less than 11. So this number is less than 18 over 4. So I'll just pick the test point to be 5 because I know that that's bigger than that. And then in the inequality, replace every x with 5. So we get 2 times 5 squared minus 7 times 5 minus 8. 5 squared is 25. 2 times 25 is 50. 50 minus 35 is 15. 15 minus 8 is 7. And the inequality, 7 less than 0, is false. So none of the numbers in the third interval are solutions. We're going to exclude the endpoints. Remember the endpoints? Those real numbers are what make 2x squared minus 7x minus 8 equal to 0. So I'll just make a note, exclude the endpoints because each endpoint makes 2x squared minus 7x minus 8 equal to 0, but 0 less than 0 is false. No number can be less than itself. Okay, so graphically we put parentheses at the endpoints, and then the interval in between the endpoints is the solution. Okay, the algebraic notation, 7 minus the square root of 113 over 4 is less than x, which is less than 7 plus the square root of 113 over 4. That's the algebraic notation. And then the interval notation, parenthesis 7 minus the square root of 113 over 4, comma, 7 plus the square root of 113 over 4, parenthesis. So algebraic notation, and then the interval notation. All right, the next page, more of the same. Okay, solve the quadratic inequality. 3y to the second plus 4y minus 4 is greater than or equal to 0. So find the endpoints. By solving the equation you get by replacing the inequality with equals. So solve 3y to the second plus 4y minus 4 equals 0. Okay, I'll turn you loose for a couple of minutes. Find the endpoints and type the endpoints in if you find them. We can solve any equation, any quadratic equation by the quadratic formula. But this one can be solved by factoring if we use the AC method. So 3 times -4 is -12. And then two integers that have a product of -12 and a sum of 4 are +6 and -2. So if we transform the trinomial into a quadrinomial, we'll replace the plus 4y with minus 2y plus 6y. And then factor by grouping. Out of the first two terms, we factor y out. And the binomial is 3y minus 2. Bring down the middle operator of addition. And then out of the third and fourth terms, factor out the greatest common factor of 2. And the binomial is 3y minus 2. So the two factors are 3y minus 2 times y plus 2. So the endpoints are y equals positive 2/3 and y equals -2. All right, so we'll plot the endpoints on the number line, -2 and 2/3. So test the three intervals. In the first interval on the left, pick any number you want less than -2. So I'll pick, let's see, the variable is y. I'll pick y to be -3. And then in the inequality, 3 times the number -3 squared plus 4 times -3 minus 4. The number -3 squared is 9. 3 times 9 is 27. 27 minus 12 is 15. 15 minus 4 is 11. The inequality is greater than or equal to 0. 11 greater than or equal to 0 is true. So all of the numbers from -infinity to -2 are solutions. In the second interval, we can pick 0. So I'll pick y to be 0. And then in the inequality, replace every y with 0. So 3 times 0 squared plus 4 times 0 minus 4 is -4. -4 greater than or equal to 0 is false. So none of the numbers between -2 and 2/3 are solutions. In the third interval, pick a number greater than 2/3. So I'll pick y to be 1 this time. Replace every y with 1. We get 3 times 1 squared plus 4 times 1 minus 4. This is equal to 3, and 3 greater than or equal to 0 is true. So all of the numbers greater than 2/3 are solutions. And what about the endpoints? The endpoints are the y values that make the left-hand side 0. And since 0 greater than or equal to 0 is true, we include the endpoints. So include the endpoints. And the reason is because 0 greater than or equal to 0 is true. So we put brackets at the endpoint, the interval to the left of -2 and the endpoint -2 combined with the endpoint 2/3 and the interval to the right of 2/3. The algebraic notation, we write y is less than or equal to -2 or y is greater than or equal to 2/3. That is the algebraic notation. The interval notation, parenthesis -infinity, comma -2, bracket, then the union symbol, and then bracket 2/3, comma infinity. Okay, the last one, what do we do on this one? X plus 4 times x minus 2 is greater than or equal to 7. Well, we'll multiply the two factors, and then after that, we'll subtract 7 from both sides. When we multiply x plus 4 times x minus 2, we get x squared minus 2x plus 4x minus 8. We're trying to find the endpoint, so I'll set that equal to 7. And then x squared plus 2x, and then when we subtract 7, we get x squared plus 2x minus 15 equals 0. And then we solve this equation for x to find the endpoints. We can factor this. One of the factors is x plus 5. The other factor is x minus 3. And so the endpoints are -5 and +3. Those are the endpoints. So plot the endpoints, -5 and 3. They divide the number line into 3 separate intervals. In the interval on the left, pick any number less than -5. So I'll pick x to be -6. Well, we could use this inequality. If you want to put this inequality in a different form, you can. Just make sure that you don't break any rules in the process. But let's go ahead and use this inequality. Replace every x with -6. So in this factor, -6 plus 4, that's -2. In the other factor, -6 minus 2 is -8. -2 times -8 is +16, and the inequality greater than or equal to 7, that is true. So all of the numbers between -infinity and -5 are solutions. In the second interval, we can pick any number we want that's between -5 and 3, so I'll pick x to be 0. And then replace every x with 0. This time we get 4 times -2, which is -8. -8 greater than or equal to 7 is false. So none of the numbers in the middle interval are solutions. In the third interval, I'll pick x to be 4. And then in the inequality, 4 plus 4 is 8, 4 minus 2 is 2, 8 times 2 is 16, 16 greater than or equal to 7 is true. So all of the numbers in the third interval are solutions. We're going to include the endpoints because of the or equal to part. And so the algebraic notation is x is less than or equal to -5, or x is greater than or equal to 3. The interval notation, -infinity to -5 bracket union bracket 3 comma infinity. Okay, we're out of time, so go ahead and sign in for attendance. I went out to the Aberdeen golf course 3 or 4 years ago. It's a pretty nice golf course.
They take sports very seriously now.
You go there to golf ever?
I don't, it was not a skill set that I could pick up. I had a lot of friends that golfed there though. So. And I haven't lived there in over 10 years, so it's been a bit. Have a good day.
You too.